So the three types of files that we'll cover are heap files, and all these files solve or are designed to actually specifically address one of the issues in terms of either the searching would be very fast or accessing the data would be fast, or one of the issues of reading, writing, or getting to the select set. But none of the file sets can actually solve all the problems. So the DBA is the one who ends up deciding, okay, this is the structure that should be, and it is totally dependent on how the data would be used. Okay, so it is the usage that decides how, because okay, you have much fewer reads or writes on this kind of data file, so let's use this kind of file structure. So that is the kind of information you want to get out of today's lecture. So we'll look at the costs of doing certain operations on all these three structures, just to give an overview, and the details would go into the lectures as we proceed, like tomorrow, Monday, Tuesday, and we'll put more into it. Actually,
to clarify before we move on, are these three opposing options and you'll choose one of them?
Yeah.
You won't choose parts of one?
No, because you need to actually define the structure of the file, and they are totally different structures.
Okay.
You'll organize the data according to what the file structure is.
Okay. And it will be global for the whole database?
No, for the file.
For the file.
Okay, because you have different files for different types of data that are being stored.
Right.
So
just to clarify, so within a database you can use different...
Yeah, you can configure, yeah.
Okay.
Mm-hmm.
Thank you.
Okay. Okay, so now the cost model that is being used is B is the number of data pages, R is records on each page, Okay, so these are the symbolic or variables that we will use just to actually compare how the time frames for different functions on these file structures go on. So let's look at the unordered ones.
What is the last word?
Heap, average, hash. Sorry. Okay, so let's look at unsorted or heap files. Okay, if we look at the time frames we again have to think of how much time each of these operations take, because then you will know what is the dominating factor. I mean, certain operations like processing and processing of any record is, I think, in the order of nanoseconds, while writing or reading is milliseconds, as we saw yesterday. So then, I mean, these things won't make any difference when we are comparing the things between. So you want to focus on how many reads and writes that come in, because that is what end up deciding how much is the time taken to execute an operation. So if you want to scan an unordered file, so to scan, we need to go through the whole file. Okay. So what we'll end up doing is the time would go into as many number of data pages are there, they'll be accessed, right? And then all those pages will have records, and this is the average time to process the record. So you will have something like B times R times C. Okay, or so this would be our scanning time for unordered file. So if we look at second operation, that is search with equality selection, so you are performing a search in which there is a constraint equal to C prime, whatever. You have a constraint, there is an equality constraint in it, and you are searching some data. So on an average, you'll have to search, you can think that 50% of the times you'll find it, right? On an average, you'll have to go through, this is the file. The data could be here or here. So on an average, when you're going through this, it'll be 0.5 is the time that would be taken for scanning. So then search with the equality selection would be 0.5 times B times D plus RC.
That's only if you're only looking for one.
Yeah, because it is equality selection.
Right, but there might be a bunch of different records with.
If you have, so you want to have multiple.
Sure, search for everyone whose age is 20. And
Exactly.
30 of those.
In that case, you have to scan the whole thing, because then this is, so I was qualifying that after this.
Okay.
That because once you do this, is if, I'm sorry?
So this is assuming that there is
Exactly. It is the equality is being used on, if we go back and think as a primary key, that the equality constraint is on the primary key, so you know there won't be any duplicates. That is when this is the case. If there are multiple selections, like if you're even looking for a range, that is the next thing also we'll go into, that if you say that you have to find records which are this, you must do a complete scan. Right? So so that was the next thing also, and they fall together in that. Okay. So now, if there is a range selection, so now we know. So let me just write down, at least for this one, let me just classify all, because it is easier. I just make the board so messy. Okay. So we have selection with the constraint. Okay, and if it is the unique or primary key, or it will be B times D plus RC if it is not a primary key. Okay, you'll have to scan the whole table. Now let's think of selection with range, in which we have C greater or less than prime, C prime. In that we will do the whole scan, so it will be B D plus RC, because we anticipate multiple copies of the thing being selected. Now if we look at insertion, so usually in a heap or unordered file, you're going to insert at the end. So you're going to get the page, insert in the end, and then write it back. Okay. So in that case, what you are going to do is you are going to get the page, okay, process it, okay, and then again write it. The thing is that you don't need to search that page, because that is the last page. So there is no searching that is going on. That is what I want you to remember, that if instead there was, if it was say an ordered one, which we'll go to, but I want you to start thinking of it right now, is if this was ordered, you'll actually have to find where to insert it. But in case of unordered, we don't need to spend that time in searching that part. So that is where it becomes distinguishable here. Okay. So then our cost becomes 2D plus C. Okay.
Could you go over what selection, how you got the value for the selection with range?
This one?
Yeah.
Okay. So if we look at this this whole table, and say we find the first entry here that satisfies this condition,
Okay.
we need to keep going because we don't know whether there are any more or not.
Right.
That is why you need to scan the whole thing.
Right.
And to scan the whole thing is, you may have these many pages which need to be read,
Okay.
right? So B pages need to be read,
Okay.
and then these many records need to be looked at.
Okay. And what's the thing after the R?
C.
Oh,
Processor record.
Okay.
Same as scan.
Oh, okay.
okay.
Right.
So if we look at, now let's look at the sorted file. So if we have a sorted file, and when you're doing a scan, you'll still need the same thing. You'll have to scan the whole, all the records of all the pages. So the time taken is the same thing, right? Because you're still going through the whole thing. So you do the same B times D plus RC. Actually, okay. So if we do a search with equality, the advantage of sorting is now you can start comparing, right? You guys did some binary search thing before, right? So now that is where then the logarithm comes in, and you have a huge improvement on your searching ability because it is sorted. So then you can go in, and so if we do a search on something that is already, so again there'll be two conditions. One is that you are searching on something that is sort by on this. If that is not the key with which you are searching, then it doesn't give you any advantage. Right? So all the performance advantage comes when you actually end up searching with the key that you have sorted it by. Okay? So then we get the same. So we have, let me just do the two cases. And then we'll have, so when we'll have the log base 2b, and because you'll have to access these many times, so d log base 2b.
Then you also
Okay.
have to scan through that particular page to find it, right?
Yeah, so but we'll have something like log 2 of c also here, right? But sorry, c log r, because that many records are there. But the thing is, it is so small, it doesn't, it would be really small as compared to this value. But a real expression would be this to get there. And if we have, so this is because I'm going through this because I think it is good while you are reading it, it'll just flow through and you'll save a lot of time in going through it. Okay. Search with range selection. Okay. So in range selection, the only difference that comes in is you'll have multiple matches. Okay, same as we did for the equality match, but now you have an introduced processing time, or you can say added time, because you will have more matches that need to be incorporated in it. But the advantage is, if you are using the sort key to do it, they are going to be grouped. So the moment you hit the first one, you know all of them are going to be there. So the time, that additional time you'll have, is the number of times to process those matches. Another thing that comes into this case, which sometimes becomes very important, is that if the selection is very big, it may span different pages. Then suddenly you hit into that you need to access the next one also. So those are the things that come as the database grows, or just to keep in mind, to have it in the back of the head. Okay. Now I need a white chalk. Oh, I found one. Okay. Insert. Insert is expensive because you need to maintain the order. So when you need to maintain the order, you need to find the point where it will go in. Now it is sorted. You need to find the point of insertion. And the other thing is, you need to actually rewrite all the pages that follow, because everything has to get skewed. Okay, so that is an expensive operation in sorted files. And what we have is, so we are going to write something on an average again, is 0.5 times B, so we'll have D plus RC here, and because you'll read that and write them, so it will be twice. Okay, because we'll have to get all of these, rewrite them back into it. Okay. Okay, now let's go into the hash files. In hash files, you guys wrote a hashing function also before, right? In one of the assignments or something, Rusty was telling me. They wrote some way back. Okay. But in hash files, what you do is you have an hashing function, and then you divide the whole file into small buckets, and each of these buckets actually conform to a certain hashing formula map. The way it is implemented is that these have only 80% occupancy. So you always implement with 20% vacant here. The advantage being that you can insert records into it without disturbing anything. Okay, because if you think of it, say there is a hashing function that creates this bucket, say now there is another record to be added, and if this is full, where will it go? Okay, so there are overflow areas, but the thing is, you want to prevent that. That is the idea. So you create an overhead of extra space for the performance base. Okay, so but then what you have to think is, you have to actually, even if the data is stored only in 80%, you need to traverse all the pages. So with the data being, say, of amount B, your time is going to be 1.25 times the B. Okay, when you compare with the other file formats, where only B would be needed, the time to traverse the thing. So our scan would then become
Where does the 1.25 come from? How's that?
1 over 0.8,
Oh, okay.
because it is 80% occupied.
Right.
So, okay. So then we go on to search. This is one function which is the hashed files are really good for searching if you are using the same key that has been used to implement the hash. Okay, so what it involves is that one is you immediately know where it is located. Okay, because you can use the hash function and actually get which bucket this record should be in. So you just do one read. You just read the bucket that in which that data is. Okay, so this will make you we'll have H for the transform, then D. Okay, now after that inside the hash there is no order, right? So then it is a regular, you'll on an average you'll do half the RC, right? Because in that then you have nothing. Okay, inside it is like an unordered file. So you just do processing on an average of half the. So now let's look at search with selection. Okay, this has a problem because now you don't know if it is going to span into multiple buckets because you are taking a range now. There is no equality constraint where you know it is going to map to only one bucket. So there is no advantage to in range selection, so you actually have complete 1.25 B D plus RC. So it is very expensive. So knowing these operations, how expensive they are, and what kind of access to your data or modification to your data is going to happen is how you decide what the file structure would be. So I think the book has a table, but I'm not sure this one of the values is correct. Can you open that table? Yeah, this one. I think it was, let me just see. I think the insert and hashed, if we look at the insert and hashed, so what you need to do is, it's like locating the, right, just read it as a single, okay, I'll read it off to the class because I don't think everybody has a, so I'm not sure if this is correct or this is how I understood, so then I thought I should bring it up. When you guys read it, just see if this is correct. So the appropriate page must be located, certainly, modified and then written back. Okay, the cost would be search plus modifying and writing back. So first you'll have to search it, locate it, and then do the operation and write it back. So that is fine. I don't understand how it can be different from deleting. But in the table they show different values for delete and insert.
Which one's more?
So they are saying that in insert you have to do 2D, while in delete you have to do search plus D. Only difference can be if they have already included the searching D for search in it. Okay, that could be the only reason. But I thought that it should be just clear that that is where it is coming from. Okay. Then it makes sense. If that is the case, then it makes sense.
The search already includes finding the page.
Exactly. So then probably that's So I just felt that in some places they have written search separately, and some way they add it directly into it. So, okay. Now let's look at the indexes and how to actually build indexes on files, and to speed up, thinking of it as like a map to be able to do searching much faster. So an index would have data entries here, and in data entries you will have something that will map to your data here. It will point to your data table, the actual data. So you can actually, so there are 3 ways to implement this. One is the data entries actually are corresponding to the data, but that is totally redundant, that it is the same thing. Okay, but there is one-to-one map, so you can think of it as sorting that data itself. If you have a data entry that is a combination of a key and row ID, where here there may be 10 different fields, but here you pick up a key and row ID 1. Say this is 1, row ID 1, so it starts pointing here. Okay, so or you could have, say, the example that there is in the book is like salary here, so you could have 10 and some. Okay. The third is you can pick up a key and row ID list. In this, then you have the list of row IDs which have the same value. So this lets you take care of the duplicates. Okay, so but then the problem with this kind of implementation is that all the data entries are going to have different sizes. So that becomes a problem. Okay, because you don't know how many row IDs will match to one particular implementation. Oh, I didn't give your book back. Is this yours? Did I give it? Oh, I don't know. Mine. Okay. Okay. So the classification of indexes goes into book has quite good pictorials of actually just understanding very quickly, looking at how they are mapping. One is clustered and one is unclustered. In clustered, what you have is there is a row in the index for each row in the data. Okay? And in unclustered, you don't have that. So this is quite good because it is very tight mapping. The problem is when you change the data, you have to modify this along with this, because there is one-to-one mapping of the index to the record. Okay. The other thing actually what happens is when you same related to the insert, or is that because of an insert this may move down to the next page, so you have to rewrite all the rest of the pages. So quite expensive to maintain. That is the problem with the clustered indexes.
Presumably, if you want to index on two different things, you can only possibly cluster them on one.
Say it again.
You might want to have indexes for a lot of different fields in your data, but you can only cluster.
Yeah, on one. Yeah, you can cluster on one, but then you can, if you want on multiple fields, you can go into the even composite indexes in which you have multiple fields defining one index.
Okay.
Right. So then what you do is, depending on how you define your index, we'll go into it after this, and you can look at it. Another classification that is about indexes is primary and secondary indexes. And primary indexes are the indexes that contain or they incorporate the primary key or the unique key in the for the data record, and secondary don't. Okay. Then it comes the composite search key. And in that, what you can have is you can have a composite index on salary, age, and row ID. And then what you will have is you'll have the grouping. In the index, you'll have grouping of salaries, and you'll have the grouping of the age. And you'll group with salary and then organize. So this is very useful when you have range questions, because you know that all of these will lie in the same area. And the advantage is that you can actually specify. So if we take the composite index, let's just take a composite index ID here. So you can have two types of queries that can be built on it. One is in which both the fields are specified. So again, that becomes the equality constraint, equality query, that both of them are qualified. So you can say salary equal to 20, age equal to 10. But if you just said salary equal to 20, then it will give you the range, because all the fields that have age immaterial to as compared as requested by the user, because you are just comparing it, that it constraint is only the salary. So let us see. So you can have, that's all. Actually, this is what they call it, that you have the two variables bound to two values, or one variable bound to a single value, and that goes into a index.
What's the downside with the composite search key is you've got lots more disk usage, because you've got to have that data replicated for each index.
So you draw a line somewhere, because it has to have then redundancy, or not. It is not really redundancy, but duplication of data everywhere that is happening.
And then also every time we have an update or delete, we have to change all of
all
those
of
indexes.
Exactly. That is the case wherever you copy data. So you just have to decide intelligently what might be best for your system. Okay. So for chapter 8 we are done. I mean, this is